Hello, everyone. My name is Jose Alvarez, and I'm a senior here at Southern New Hampshire University in the computer science department. And I've been in the program for about 2 years now. In my personal life, I work as a system analyst for a hospital system, and my ultimate goal is to become a software developer or software engineer working as a full time developer. The artifact that I chose is our Travlr Getaway full stack application that was developed in CS 465 full stack development. And the scenario for that project is that we are working as a software developer for a development company, and we are assigned to create a new travel booking application for our client, Traveler Getaway. The client in this scenario wants two things: a public facing website where customers can browse travel packages, view details such as destination, descriptions, images, dates, and pricing. And the broader client vision is going to also allow the customer to create accounts, search for packages by criteria such as location and price, make reservation, and then view the itinerary. Uh, they also wanted us to develop a separate admin only application where their employees can maintain travel packages, pricing, customer related information there. So to begin, we're going to walk you through the project and how it's structured. So this project has three main parts that kind of work together. We have our app admin, our app API, and an app server. So kind of starting at the top here, we'll go ahead and look at our app admin at a high level. Of course, we'll come back here, but uh, our app lives in the source code here. And this is going to be our single page application, which you will hear me refer to it as SPA. And this is going to run separately from our customer facing website, and it will allow the administrators to edit trip details, add new trips, and just ultimately view customer information as well. Uh, the next piece is under the app server, and this is where our customer facing web page lives. And we built this page using Express and handlebars for server side rendering, which has some SEO benefits. And we also utilize the model view controller architecture here. So everything that the customer sees on our website kind of lives in these different uh, controllers, routes, and views here. The last piece, which is my personal favorite, is our app API, which is where all of our business logic happens. We have our controllers, which is going to handle the request from our website, the model, which contains all of our DB schema, our MongoDB schema here, and then our routes here. This kind of wires those all those pieces together. So jumping into our website, you can see I've went ahead and started our customer facing website as well as our admin website, and we'll just go ahead and jump in. So here is our customer facing website, Traveler Getaways. You can see we have different tabs at the top. We have our home page, which is going to kind of give kind of broad overview of the website in one page here, which you can click out the different links for rooms, travel, food, etc. We have our travel page, which contains our different destinations here. You can see there's photos, descriptions, etc. Rooms are the different rooms that are available, meals, different news and blog articles can be found here, our about page. And then lastly, we have a contact page, which allows the user to fill out some information and contact Traveler Getaways. Jumping over to our admin portal, this is what the employees will see when they open this page. We'll go ahead and log in. So we have the ability to log in at the little blue hyperlink there. So we'll go ahead and type in Joe Smith. Once logged in, we have the ability to add new trips if we need to. So if I click add trip, we can go ahead and add the data for the trip and save it. And then going back, we can also, once those trips are added, we can edit any of those trips here. So we can edit different information about the trip. Let's go ahead and jump back into VS Code. So before I discuss each of the three enhancement categories, I want to briefly explain how the application is organized internally, because understanding the overall architecture will make it easier to see how the different pieces of this application work together and why I selected this artifact for my enhancements. Perhaps the biggest strength of this project is that it follows separation of concerns by separating the responsibilities into different layers. Rather than placing all the code in like this big monolith, uh, it separates into individual components that each perform a specific responsibility. Now, that's great practice because it's going to improve maintainability of the code, readability, as well as scalability as this code grows. So we're going to start here in our app.js file, and this is going to serve as the entry point for the Express application. This file here is responsible for configuring the application. It imports major components, it initializes the middleware, establishes our database connection, configures authentication, and maps incoming requests to the appropriate routes. One thing I appreciate about this design is that the app.js contains very little business logic. Instead, it acts as the application coordination by delegating those responsibilities that we were talking about earlier. And that makes this application easier to understand because each component has a clearly defined purpose. So you can see we're initializing a lot of our, or importing a lot of our components here, and then kind of line down here at line 20, this is where the application initializes the MongoDB database connection, which centralizes the database configuration in its own module, meaning that the controllers and routes don't need to worry about how the database connection is established. They simply rely on it being available when they need it. Scrolling down a little bit, line number 27 here. Um, this is where we are going to initialize Passport, which is going to be our application's authentication framework. Rather than implementing custom authentication logic throughout the application, Passport is going to provide a centralized solution for validating user credentials. Scrolling down a little further here, uh, looking at line 46, we're going to enable our cores. This is going to allow our SPA to communicate with our customer facing website and API, which are running on different ports. So without that, those ports would not be able to share data between the two. So that's very important here in this file. Then the last thing we'll look at is down a little further here on line 54. This is where we are going to have our routes. So the application is going to map those incoming requests to their corresponding routes instead of handling the request directly inside app.js. Responsibility is delegated to the route files that specialize in specific parts of the application. Another strength of this project, as I mentioned earlier, is the model view controller architectural pattern, in which the model manages the application data, the view is the information that's presented to the user, and the controller contains that business logic that connects those two layers together. Separating these responsibilities makes the application easier to maintain, easier to test, and easier to extend as new functionality is added. So let's go ahead and open up in our app server. We'll go ahead and go to routes, and we'll open up our travel.js folder here. This is representative of our routing layer, which serves as the entry point for incoming requests. The primary responsibility is determining which controller should respond when a particular URL is requested. By keeping routes lightweight, the application avoids mixing routing logic with business logic. Um, let's go ahead and open up our controller here. And another good one is travel.js. The controller contains the application's business logic. So they're going to receive those requests from the routing layer, and then they're going to go ahead and retrieve and manipulate data through the models and determine what information should ultimately be presented to the user. Controllers effectively coordinate communication between the other layers of the application. So moving on to our models, let's go ahead and close these down to make it a little easier here. We're going to go ahead and open up our API folder and models, and we'll go ahead and open up our traveler.js. Models define the structure of the application's data. So in this project, Mongoose models define how trip and user information is stored within the MongoDB. By centralizing the schema definitions, the application maintains consistency whenever data is created, updated, or retrieved. And lastly, we'll look at views here. So I'm going to close the API. We'll open up the views folder in our app server. And let's go ahead and look at travel.hps. Um, again, the view layer is responsible for presenting information to the user. So in this example, specifically, we'll highlight this chunk of code here. In this example, the handlebars template loops through each trip returned by the controller and dynamically inserts the trip information into the HTML page. Um, and you'll notice that the view doesn't communicate directly with the database or contain any business logic. It simply renders the data it receives. Now that I've explained the overall architecture of the application, I'd like to move on to the first enhancement category, which is software engineering and design. The area that I chose to focus on here is authentication because it touches multiple layers of the application. So I'm going to go ahead and close out of this here. We're going to open up our app API folder, controllers, and then we're going to take a look at our authentication.js folder. Uh, this controller exposes two REST API endpoints. So we have our register function here and our login function. That's the two we're going to be looking at. During our registration, kind of looking over here, it's going to validate that all the parameters are present. And then once it's validated for those elements are there, it's going to create a new user. Um, it's going to hash out the password for that user. And then it's going to go ahead and save that to our MongoDB. And also, kind of at the end there, it's going to return that JSON web token. Um, During our login function, the controller again is going to validate incoming requests. Um, it's going to delegate the authentication to the passport module. Um, and if the user credentials are valid, it's going to generate another JWT token um, and return that to the Angular client. Um, so let's go ahead and dig a little deeper into that passport .js, and that's going to live in the config file here. We'll go ahead and open that one up. Um, so looking at this file, this is going to handle the actual credential verification. So instead of storing passwords in plain text, the application retrieves the user by email. So you'll see we get that username field, and then we'll go ahead and search for the email in the database. So you'll see this find one here. Um, And this is a much more secure approach than just storing passwords directly, because even if the database were compromised, the original passwords would not be exposed. And then finally, the passport is going to finish verifying the user's credential uh, and returns to the authentication controller. So it'll just return that response. Moving on a little bit, we're going to look at on the client side, the authentication service. So I'm going to go ahead and close this down. I'm going to go ahead and close these files just to make it easier to move around. Let's go ahead and go to our app admin. We'll open up our source file, services, and we're going to go ahead and open up our authentication.service.ts file here. Um, I want to point out our login here, which is essentially going to log in the user with their username and password, and it's going to return a JWT, and it's going to call that save token, which if I scroll up a little bit, or see it right here, and it's going to save that Travlr token here. And we also have helper methods to get that token if we ever need to. So we need to validate that the user is logged in. We have our get token here. We can check to see if our user is logged in. Again, that's going to be calling that get token. And then we have logout, which will remove the Travlr token, essentially causing the validation to fail if the user tries to do anything with our data. Overall, I believe the authentication architecture is well organized. Responsibilities are clearly separated between the controller, passport, Angular services, and the user interface, which makes the application easier to understand and maintain. However, my review also identified several opportunities for improvement. The first opportunity for improvement I identified relates to configuration management. So we're going to go ahead and close this out, and we will open up our trip data services.ts file here, and we will go ahead and look at this line of code here. So currently, the API endpoints are hard coded directly into the Angular service. And while this works during development, it makes the application less flexible because any environment change would require modifying this source code here. A more maintainable approach would be to move these values into Angular environment configuration files, which would allow the application to easily switch between development, testing, and production environment without requiring any code changes. So this enhancement improves maintainability, and follows modern software engineering practices. The next improvement I identified involves how errors are handled throughout the application. So I'll go ahead and close this one down, and we are going to open our authentication service.ts. And what we are interested in um, is right here in our error handling. So currently, authentication errors are simply written into the browser console. And so while this is helpful during development, it doesn't provide meaningful feedback to the user and doesn't establish a consistent error handling strategy throughout the application. So you can see that here. We have that again hard coded here. So as part of my enhancement, I plan to implement standardizing API responses along with more informative messages within the Angular interface. This will improve both the user experience and make future debugging much easier. Um, Another area that can be strengthened is the application's authorization method. So we'll close out of this. I'm going to close this down here. We'll open our API, and inside of our routes folder, we have our index.js. And what we are specifically interested in is right here. So these couple of lines here, our post method adds a trip, and then our update trip method here. So one thing the application already does well is protecting administrative endpoints using that JWT authentication. Before allowing a user to add or modify the application, it's going to validate that JSON Web Token. However, every authenticated user currently receives the same permissions. So the enhancement I plan on implementing is role-based authorization, which would allow administrators to create, update, and delete trip information while restricting other users to maybe read-only functionality. And the final software engineering improvement I'd like to discuss relates to the overall application maintainability. So I'll close this down here. I'm going to close this down as well. And we'll go ahead and open up our app.js. And we'll revisit the cores that we talked about earlier. So during our review, I noticed that several application settings are currently hard coded into the source code. So this is a great example here because it explicitly specifies the development origin. And while this is perfectly acceptable for our local development, production applications typically externalize these values using environmental variables. So as a part of my enhancement, I plan to improve the configuration management by moving deployment specific settings out of the application code, which will improve portability and make the application easier to deploy in multiple environments. Overall, I believe the application demonstrates a solid software engineering foundation with a well organized architecture and clear separation of responsibility. My planned enhancements focus on strengthening that foundation by improving configuration management, error handling, authorization, and overall maintainability rather than redesigning the application. And with the software engineering review complete, I'd now like to move on to the second enhancement category, which is algorithms and data structures, where we'll discuss the how the application retrieves and processes trip data and the enhancements I plan to implement. I'll begin by explaining the current implementation before discussing the opportunities I identified for improvement. The primary service responsible for retrieving trip data is the trip data service file. So I'm going to go ahead and close out of this, and we're going to open up our admin file. And inside of our services file, we are going to find our trip data service. This service acts as the communication layer between the Angular application and the Express API. Rather than allowing individual components to communicate directly with the backend, all the trip related operations are centralized into this reusable service. This service currently supports retrieving all trips, retrieving an individual trip, so get trips, get trip, creating a new trip, and updating an existing trip. This design follows good software engineering practices by separating data access from the presentation layer and encouraging code reuse throughout the application. Once the service retrieves that data from the API, the next step is going to be displaying that information to the user. So where we'll find that is going to be in our trip listing component. So let's go ahead and open trip listing, and we'll open our trip listing component.ts file here. And we're going to specifically look at the get stuff method um, and the this.trip data service.get trips. The trip listing component requests all available trips from the service and stores the results inside an array of trip objects. Angular then uses that array to dynamically generate the list displayed within the administrative interface. This implementation is simple, easy to understand, and it works well with a relatively small number of trip records. Although this approach does work well, reviewing the implementation also highlighted several opportunities to improve how data is processed as the application grows. So, looking at our Git trips here, currently the application retrieves every trip from the database each time the page loads. And again, this is perfectly acceptable for a small number of records, but it becomes increasingly inefficient as the number of trips grow. Every record must be transferred across the network, even if the user is only interested in a small subset of those trips. So, one enhancement I plan to implement addresses this by allowing the application to retrieve only the information the user actually needs. So, my first enhancement will introduce server side filtering. Instead of requesting every trip, the user will be able to search based on criteria such as destination, trip duration, price range, or availability. The API will then construct a query that returns only the matching records, which will reduce unnecessary data transfer while improving responsiveness and scalability. Another useful enhancement involves giving users greater control over how search results are presented. In addition to filtering, I plan on implementing dynamic sorting. Users will be able to organize trips by criteria such as destination, price, or trip duration. Rather than retrieving all the data and reorganizing it on the client, the application will perform the sorting before the results are displayed, which creates a more intuitive and user friendly browsing experience. Um, as the amount of data continues to grow, another challenge becomes presenting that information efficiently. So currently, every matching trip is displayed at once. And while this works well with a small number of trips, it's going to become less practical as the number increases. So to address this, I plan on implementing pagination so that results are divided into smaller and more manageable pages, which reduces the amount of data displayed at one time. It improves the page responsiveness, and then it creates a more scalable application. So together, these enhancements also improve the algorithms the application uses to retrieve the information from the database. From an algorithmic perspective, the current implementation follows a straightforward process by requesting every trip from the database, storing that in memory, and then displaying that record. And that is simple and effective, but it's going to become less efficient as the data set grows. My enhancement shifts much of that processing to MongoDB by allowing the database to perform filtering, sorting, pagination before the data is returned to the application. This is going to reduce unnecessary processing within the Angular client and minimize the amount of data transferred across the network, resulting in a solution that's both more scalable and more efficient and also more enjoyable to the end user. With the algorithms and data structures review complete, I'd now like to move on to the final enhancement category, which is databases. In this section, I'll discuss how the application currently stores and retrieves information, examine the existing database design, and explain the enhancements I plan to implement to improve data integrity, scalability, and overall database performance. So we'll begin with our database configuration. So I'm going to go ahead and close out these files here. We'll collapse everything down just to make it a little bit easier to work with. Let's go ahead and open our app API, models, and we'll open up our db.js. The first thing we'll look at is this connection string here. So this file, it establishes the connection between the application and the MongoDB using Mongoose. One thing I like about this design is that the database connection is centralized into its own module, which allows the rest of the application to interact with the database without worrying about how the connection is established. Separating database configuration from business logic improves maintainability and follows good software engineering practices. Um, Once the database connection has been established, the next step is defining the structure of the data that's stored in MongoDB. So we'll go ahead and open our Travlr.js file here, and you'll notice that we have our trip schema listed. So the trip model defines the structure of every trip document stored within the database. Each document contains information such as trip code, destination, resort, trip length, pricing, image, and description. By defining the schema in one location, Mongoose helps ensure that every trip follows a consistent structure throughout the application. This consistency simplifies development because controllers and services can rely on the same data model whenever trip information is created, updated, or retrieved. In addition to storing trip information, the application also manages user accounts for the administration authentication. So let's go ahead and open up our users.js file here. Um, and we have a couple of nice functions here, such as our set password, validate password, generate JWT token. Um, the user model is responsible for the securely storing administrator account information. Rather than storing passwords directly, the application generates a unique salt and password hash for every user. The model also contains those helper methods for validating passwords and generating JSON web tokens. This approach provides a much stronger level of security while keeping authentication logic centralized within the model itself. Let's go back to our Travlr.js file. The first opportunity involves strengthening schema validation. While the current schema defines the structure of each document, additional validation rules could be added to ensure data quality. For example, fields such as trip code, destination, and price could enforce stronger validation requirements, helping prevent incomplete or inconsistent data from being stored within the database. Improving validation increases data integrity while reducing the amount of defensive programming required throughout the application. Another enhancement focuses on improving database performance as the number of stored trips increases. Currently, MongoDB performs well because the dataset is relatively small. However, as additional trips are added, searching for information becomes increasingly expensive if the database must examine every document. To improve performance, I plan to introduce indexes on the fields that are frequently searched, such as trip code and destination. Indexing allows MongoDB to locate matching records much more efficiently, resulting in faster searches and improved scalability. Beyond improving existing collections, I also identified an opportunity to expand the overall data model. Currently, the database primarily stores trip and user information. To better simulate a production travel application, I plan to introduce an additional collection for bookings. Each booking would associate a user with a specific trip while storing information such as the booking date, number of travelers, and reservation status. Adding this collection creates a more realistic database design while demonstrating relationships between MongoDB collections. Finally, I'd like to discuss one enhancement that ties together both database and application security models. Uh, so we'll go ahead and open up our route routes folder and our index.js file. And particularly, we are interested in our authenticate JWT method. The application already protects create and update operations using JWT authentication. As a part of my enhancement, I plan to build on that foundation by combining stronger schema validation with role based authorization. Together, these improvements ensure that only authorized users can modify data while also preventing invalid information from being stored within the database. This results in a more secure and reliable application. Overall, I believe the current MongoDB implementation provides a solid foundation for the application. My planned enhancements focus on improving data integrity through stronger validation, increasing performance through indexing, expanding the data model with additional collections, and strengthening secure database operations. Together, these improvements demonstrate practical database design principles while making the application more scalable, secure, and maintainable. This concludes my review of the three enhancement categories. Throughout this review, I've discussed the current implementation, analyzed opportunities for improvement, and outlined the enhancements I plan to complete during CS 499. These enhancements will strengthen the application's software engineering design, improve the efficiency of data processing, and create a more robust and scalable database architecture while demonstrating the knowledge and skills I've developed throughout the computer science program.